All right, homework day 24. Solving systems of equations. System of equations is when you have more than one variable, and when you have a system of equations, the number of variables you have corresponds to the number of equations you have to have. So if you have two variables, you have to have two equations. If we would have three variables, we'd have to have three equations, and so forth and so on. We're just going to do ones with two variables. There's a whole lot of ways to solve system of equations. If you get to college algebra, we'll probably solve it 5 different ways. But in introductory algebra, we're just going to do it 2 different ways. One way is solving by substitution. If one of your equations is solved for x or for y, or it's easy to solve it for x or y, we can solve by substitution. What we're going to do is replace the y in our other equation with what y is equal to. In this case, y is equal to 2x plus 4. So in place of that y down there, we're going to put parentheses and we're going to put the 2x plus 4 in its spot. So rewriting the second equation, we're going to have 5x minus 2, and then in parentheses, where the y was, we're going to put the 2x plus 4. And then we're going to have equals the negative 9. Now we have an equation that just has one variable. Looks like those big long ones that we solved in chapter 1. And so we have to first of all get rid of the parentheses. So 5x, negative 2 times 2x would be minus 4x. Negative 2 times 4 would be minus 8, equals our negative 9. Next thing we did was combine our like terms. 5x minus 4x was x. X minus 8 equals negative 9 then. And then in order to solve that for x, we've got to move our 8 to the other side. So we're going to add our 8. X equals negative 1. So there's going to be a box that says x equals and y equals. We know that x equals negative 1. We still need to find what the y value is. So what we're going to do is go back to this first equation that said y is equal to 2x plus 4. But now we know what x is, so we can put the negative 1 in for the x. So 2 times negative 1 plus 4. 2 times negative 1 is negative 2. A negative 2 plus a 4 is a positive 2. Y equals 2. Now if we really weren't sure if we did it right or not, we could check our answer by using this second equation and putting in the x and the y value. If I take 5 times the x value of negative 1 minus 2 times the y value of 2, do I get negative 9 for an answer? Well, 5 times negative 1 is negative 5. Negative 2 times 2 is minus 4. Sure enough, I do get negative 9, so yep, it checks out. I know I did it right. So negative 1 and 2 are your answers. Got all that written down before I move the board. Number 2 then. Now notice this one, it has x minus 3y equals 19 and 3x plus 2y equals 2. Neither equation is solved for x or for y, but it's easy to solve that top equation to get the x by itself. If I want to get the x by itself, I'm going to put the y on the other side, so I'm going to make it plus 3y. So now x equals 19 plus 3y. Now my equation is solved for x. So that means in the second equation, I'm going to replace the x with 19 plus 3y. So if I do that, what would I have?
So 3 parentheses, 19 plus 3y, parentheses, equals x.
Whoops.
Whoops. Plus 2y.
We need plus 2y equals
Equals 2.
2. There's what we should have. So we just replaced the x in that bottom equation with the 19 plus 3y, and everything else just came down. In order to solve that, we have to start by using our distributive property. So 3 times 19 first. 57. 3 times 3y
9y.
plus 9y. And then we're going to bring down the plus 2y equals 2. That wasn't in the parentheses. Next thing we want to do,
57 plus 11y.
57 plus 11y equals 2 because we combined our like terms. Then we're going to subtract the 57 to get the y by itself. So minus the 57, 11y would equal negative 55, right? And then divide by 11. Y equals negative 5. By the way, if that's not coming out to a nice integer, a nice whole number, we know something's wrong because you're not going to get any fraction answers. So we found the y was equal to negative 5. We want to now find what the x is equal to. What equation should we probably use to find out what x is equal to? This top one that we rearranged because we solved that for x, right? We said that x was equal to 19 plus 3y, but now we know that y is a minus 5, right?
Yep. So we go 19 plus 3 times negative 5.
And then if we simplify that, 19 minus 15 is 4. So if we just check it quick in our head, 3 times 4 is 12. 2 times negative 5 is minus 10. 12 minus 10 is 2. Yep, my answer checks out. So, not short problems. So number 3, we have 5x plus 4y equals 3 and 3y minus 7 equals x. So we do have that bottom equation solved for x. They just wrote it backwards to see if they could mess you up. Since this one is solved for x, we can use our top equation and replace the x with the 3y minus 7. So if we do that, what would we have?
3y minus 7 parentheses plus 4y equals 3. Okay.
Getting rid of our parentheses, we then would have
15y minus 35 plus 4y.
So 15y minus 35 plus 4y equals 3. Then we're going to
19y minus 35.
combine our like terms. So 19y minus 35 equals 3. Then we would
Subtract 30, no, add 35.
add 35. 19y equals 38.
Divide by 19.
And divide by 19. So
2.
y equals 2. We found y. We need to find x. How are we going to find x? Substitute that into our second equation. 3y minus 7 equals x, and we know that y is going to be 2, right?
3 times 6 minus 7 equals 1.
Equals what?
Negative 1.
Negative 1. And so we say, okay, 5 times negative 1 would be negative 5. 4 times 2 would be 8. Negative 5 plus 8 is 3. Yep, checks out. We did it right. Always good to check your answer just in case you got positive 1 instead of negative 1, right?